I've always been fascinated by 3D printers. What used to only exist in science fiction stories is now a real, tangible product that you can use to print your own three-dimensional objects. The only downside is that they can range from hundreds to thousands to tens of thousands of dollars. What I want to do is see if we can build one for less than $100. Obviously, this isn't going to be anything fancy, but it should show you the basics of how 3D printers work and what you can do with them. Alright, let's sketch. The basic components we need to make a 3D printer are long strips of plastic called filament, a hot end device that can melt the filament, an extruder that pushes it through the hot end, and an X, Y, and Z axis that can move it around a plane. So how can we do this as cheaply as possible? Well, if you've been following along with my videos, I've already shown you how you can make an Arduino controlled X, Y, and Z axis CNC machine using old CD-ROM drives and a desktop PC power supply. Assuming you could scavenge the desktop power supply and the drives, that whole project should have cost around $20 or less. That leaves us $79 for filament, a hot end, and an extruder. Buying pre-made extruder hot end sets for consumer 3D printers are really expensive. So two alternatives I thought of were a hot glue gun and a 3D printing pen. A hot glue gun would be cool, but it would require us to build a motorized extruder from scratch, which again can get really expensive and complicated. So the best option for this project is this $45 3D printing pen, and it even comes with its own filament. If we can get this to work, that would make it a $65 3D printer. Taking a look at this pen, it's operated by a speed controller, a forward extrusion button, and a reverse button. What we want to be able to do is automate this forward extrusion button. So the idea here would be to control this button using the Arduino from our CD-ROM CNC machine. So let's rip this thing apart and see what we can do. Remove the back plate and lift it off, then remove this top screw and these two connectors to disconnect the top end. You should just be able to pry it off. Remove the speed slider by pushing it away from the metal arm and then remove the metal arm. Unscrew the tube clamp, then just lift up on the far end of the main board to remove it and the tube. Then the hot end should just be able to snap off the front. This is the button we're interested in. You can see 4 tiny pins off to each side of it. We want to see which pins we can connect to trigger the motor. So reattach the hot end and the power cables and then plug it in. Push the button to start the heat up process, and when the ready light turns green, take a 1K ohm resistor and touch one end to one pin and the other end to another pin. At least one combination of pins should start the motor. Once you figured that out, with the device unplugged, solder a long piece of wire to one pin and a second long wire to its pairing pin. The pins are very tiny, so be careful not to use too much solder and let it get out of hand. Then when you're through, plug the device back in and test it out by touching the 2 wires together with a 1K ohm resistor to see if the motor starts spinning. If it does, then you can put some hot glue on the wires to hold them in place and then reassemble everything back together. You can drill or cut a small hole into the back panel to accommodate for the switch wires. Now we need to figure out how to trip the switch using the Arduino. The key is this, a transistor. For this project, we'll be using it like a switch. It has 3 pins, a collector, a base, and an emitter. We can connect one of the switch wires to the collector pin and one to the emitter pin. Then when we apply an electrical signal to the base pin, it should switch the button on. Killing the signals should switch it off. To do this using an Arduino, we can connect a ground pin to the collector pin and pin 12 on the Arduino to the base pin. Why pin 12? Because this is what Gerbil uses to control the spindle motor on a CNC machine. Since the current for the button is very low, we'll need to add a resistor to limit the current from pin 12. I'll be using a 22K ohm resistor, but this may vary depending on what type of 3D printing pen you're using. This is what my actual breadboard circuit looks like. And when you have everything connected, wire it all back up to the CNC machine and mount your 3D pen to the Z-axis using hot glue so we can test it. Let's just test the extruder button first. Power everything up and connect the Arduino to your computer. Open up the Gerbil controller software and open the Arduino link and check this box. The motor should turn on. Uncheck it and it should turn off. And if you look in the panel to the left, you should see the Gerbil command to turn it off is M3 and to turn it on is M5. We'll need to remember these codes for later. Now we want to print something. I'm going to be using makercam.com again because it's super simple and editing the code afterwards will be easier. I'm just going to insert a basic star, switch it to centimeters, rescale it to fit within the smallest corner box, and then under cam, follow path operations, we'll need to tweak the settings a little bit. The tool diameter isn't really needed, and the target depth is actually going to be the height that we want our object to be. Mine is -1. It's negative because CNC drills go down. Positive numbers won't export any code because holding a drill above a surface doesn't yield any results. Set the safety height and the stock surface to 0 and the step down to however thick you want each layer to be. I found that 0.2 works well with the 3D pen at its slowest speed. Speaking of speed, the feed rate is how fast the machine prints out. I found that 50 millimeters a minute works well with the speed of the extruder. The plunge rate is the up and down motion of the nozzle, and it doesn't matter too much, but I set mine to 50 as well. Click OK, go back to cam and calculate all, and then go back to cam and export the G code. Now we'll need to edit the G code to work with our monstrosity that we've created. So open up that file in a text editor such as Notepad, and you can see a lot of lines of different G code. Starting at the top, it sets the initial Z-axis to 0, which is the base level. We want ours to be the same height as our first layer, which is -0.2. It then starts the extruder motor and moves to the first location. But we don't want to start the extruder motor until it has reached the first location, so move the M3 command to after the first F or feed rate command. Then you have the first X and Y movements followed by the Z-axis movement to 0. We don't want our Z-axis to move to 0, but instead we want to stop the extruder motor before we move the Z-axis again. So replace this with the M5 command to stop the extruder. Then after the next feed rate command, start it again. Continue this pattern of replacing all the Z0s with M5s and adding M3s after each feed rate command until you reach the end of the document. Remove this final Z0 command and then after the M5 command, set the Z height to a value above your final object's height. Since mine was -1, I'm going to set my final value to -2. Another good command to add is this, which sets the X and Y axis back to their starting locations. Alright, now save it, make sure the CNC machine and 3D pen are fully powered on and heated, and then using the extruder buttons, feed some filament through the pen so that it comes out the hot end. Clean the hot end and then position the pen all the way down so that the tip just barely touches the Y axis. Open up the Gerbil Commander and connect the Arduino, and then load the file that we just saved. Then click Begin. If everything works well, it should start printing. Congratulations, you just made your first 3D printer. Now you can experiment with different shapes and fills and see what you can create. If you're able to make anything pretty cool, please feel free to share it with us in the comments below. Alright, what idea would you like me to cover next? Submit or vote for your favorite ideas at tinkernut.com/ideas. Click here to watch my last video, and if you'd like to support my show, please feel free to like, subscribe, comment, follow me on social media, or donate at tinkernut.com/donate. Alright, that's it for this tutorial. For more, go to tinkernut.com.